Imagine you're on a beach at midnight. No city lights, no moon, just darkness and waves rolling in. Then you step into the water and the ocean lights up. Every splash glows electric blue, like the sea itself is alive with cold fire. This is called bioluminescence, living light. It's evolved independently at least 40 separate times throughout the history of life on Earth. That's not coincidence. That's nature discovering again and again that making light is worth the cost. So how does a living thing produce light without heat or electricity? The answer is chemistry. A molecule called luciferin reacts with an enzyme called luciferase, add oxygen, and instead of heat, you get pure cold light. Almost nothing is wasted in the process. No smoke, no flame, no burning of any kind whatsoever. Engineers and physicists have spent decades trying to build artificial light sources even close to this efficient and clean. Nature solved this exact problem roughly 500 million years ago, and it never even needed a battery, a wire, or any power source at all. So who actually glows down there in the dark water? The most famous glow comes from something microscopic, dinoflagellates. Billions of single-cell plankton drifting near the surface disturb the water even slightly with a wave or a hand, and they flash brilliant blue. Multiply that by billions of cells at once, and you get the glowing waves people film on beaches in Puerto Rico, the Maldives, and California, traveling thousands of miles just to witness it in person. Jellyfish glow green too, and one particular species changed the course of modern science when its glowing protein became one of the most widely used tools in biology and medicine. Anglerfish dangle a glowing lure above their jaws in total darkness. That light doesn't even come from the fish itself. It comes from bacteria living inside the lure, a deal struck over millions of years. Shelter for the bacteria, a flashlight for the fish. Firefly squid light up entire beaches in Japan when they wash ashore by the thousands every spring, turning the sand itself electric blue. Vampire squid spray glowing mucus at predators as the defense, buying time to escape. And the cookie-cutter shark glows across nearly its entire body, except for one dark band near its head, creating a fake silhouette that tricks much larger fish into attacking what looks like small, easy prey. Deep-sea worms drop glowing scales as decoys when attacked, distracting predators just long enough to escape into the surrounding darkness. And entire bays in places like Vietnam and Australia turn brilliant blue every single night, drawing tourists who paddle quietly through water that genuinely looks like liquid starlight under their boats. Let's go deeper into the chemistry because it's genuinely beautiful. Different creatures use completely different versions of luciferin. The molecule inside a firefly isn't the same one found inside a deep-sea fish or inside a glowing plankton cell. Evolution kept rediscovering this same trick again and again from totally different starting points across the tree of life. And the color isn't random. Most ocean bioluminescence is blue because blue light travels the farthest through seawater. Red light disappears within a few meters. Blue light can travel for hundreds of meters in that same water. Over millions of years, the ocean tuned its living light to the one color that actually works best underwater. Some predators took this even further. Certain deep-sea fish evolved the rare ability to produce red light, paired with eyes specially sensitive to that exact wavelength that gives them a private channel, invisible to everyone else. They can clearly see their prey illuminated in red, while their prey has no idea they're being hunted by an invisible spotlight. This whole system runs on a precise molecular switch. Nerve signals trigger the reaction in milliseconds, and the creature can turn its light on and off almost like flipping a tiny biological lamp, controlling exactly when and how brightly it glows. So, why glow at all when it costs energy to produce light? There are at least 5 different evolutionary reasons. The first is camouflage. Many open ocean fish glow specifically on their bellies to match the faint light filtering down from above, erasing their own shadow and making themselves disappear when viewed from below by a hungry predator. The second reason is luring prey, exactly like the anglerfish, dangling its glowing lure patiently in the dark. The third is startling. A predator outright, or in some surprisingly clever cases, calling in an even bigger predator to attack whatever happens to be attacking you, turning the tables completely in an instant. The fourth reason is communication. Fireflies flash in precise coded patterns to find mates of their own species, and some females fake another species pattern entirely just to lure in an easy meal instead of a partner. The fifth reason works like a living burglar alarm. Touch certain deep-sea creatures, even briefly, and they light up immediately, summoning something much bigger to deal with the threat on their behalf. So what does this mean for us? More than you'd think. The glowing protein from one jellyfish species won its discoverer as a Nobel Prize. It's now used to literally watch cancer spread through a living body in real time, to observe neurons firing inside a living brain, and to track viruses moving between cells in laboratory experiments. Scientists have engineered glowing plants as a proof of concept for ambient lighting that needs no electricity at all. Bacteria that glow when they detect pollution are now used as living environmental sensors, dropped directly into rivers and lakes to flag contamination almost instantly. And that same chemistry sits inside rapid diagnostic tests used in hospitals around the world today, helping doctors detect infections in minutes rather than days. The cold, quiet light of the deep ocean has genuinely become part of modern medicine, sitting quietly on laboratory benches everywhere. But here's what keeps marine scientists up at night. We've explored less than 20% of the entire ocean floor, even now, in an age of satellites and submersibles. And in that small fraction we have explored, researchers estimate that 76% of all species living in the deep ocean are bioluminescent. Down there, glowing isn't rare. It's simply the default. Darkness, strangely, turns out to be the exception. And it isn't only the ocean that glows. Some species of fungi growing on rotting wood in forests around the world produce a faint green light too, for reasons scientists still don't fully understand. Even a few earthworms and millipedes quietly glow beneath the soil, completely unseen by anyone walking above them. So the next time you're near the ocean at night, try cupping a little water in your hands. In the right season, on the right beach, you might catch it. A faint, cold, electric blue shimmer glowing softly in your palm. A billion years of evolution, quietly glowing for just a few seconds before fading away again. If you found this beautiful, go ahead and subscribe. Next week, we're looking at a tiny creature that might genuinely be biologically immortal. And yes, it's completely real.